Types of functions. First, 1 injective and many one functions. A function f from x to y is said to be 1 if every element of y has only one preimage in the set X. Otherwise, it is called many one function. That is, for every x1, x2 in X, fx1 is equal to fx2 implies that x1 is equal to x2 for f to be 1. Otherwise, many one. So you can see fx1 and fx2 are images, and if these are elements of set Y, they are same, then pre-images must be same for being 1. Let us do a question. Question number 1. So that the function f from x to y given by fx is equal to 3 minus 4x is 1. Solution. We have to take two elements x1 and x2 from X, then fx1 is equal to fx2 implies that x1 is equal to x2 is to be shown. So let x1 x2 belongs to X. Now fx1 is equal to fx2 implies that 3 minus 4x1 is equal to 3 minus 4x2. This implies that minus 4x1 is equal to minus 4x2. This implies that x1 is equal to x2. Hence, f is 1. Check whether the function f from R to R given by fx is equal to mod x is many one. Solution. For minus 1 and 1 in domain R, f minus 1 is equal to 1 is equal to f1, because fx is mod x, so f minus 1 is mod minus 1. which is 1. This implies that f is many 1, because here an element 1 of codomain R has two pre-images -1 and 1. Let us see next type of function. Let us see it visually. So here you can see every element of this set. Let us name it. This is x, this is y, this is x, this is y. So you can see every element of set y has only one pre-image in set x, so it is 1 1. But here you can see uh, an element 1 of set y has more than one pre-images a and b, so this is many 1. Let us see next type of function, which is onto surjective or into functions. A function f from x to y is said to be onto if every element of y if every element of y if every element of y is an image that is otherwise it is called into. That is, for f to be onto, for every y in capital Y, there exists an element x in x such that fx is equal to y. Otherwise, f becomes into. In this case, onto a range of f is equal to codomain of f, while in the case of into, a range of f is a proper subset of codomain of f. Let us do a question. So the question is, so that f from R to R given by fx is equal to 3 minus 4x is onto. What to do here? Let y belongs to codomain R. Then y is equal to 3 minus 4x implies that 4x is equal to 3 minus y. This implies that x is equal to 3 minus y by 4. So this is the first step. The first step is we have to take fx as y and convert y convert x in terms of y. Now we have to show fx is equal to y. So now fx is equal to, here x is 3 minus y by 4, and fx is 3 minus 4x, so 3 into 4, here 3 minus y by 4, 4 is cancelled, so we have 3 minus 3 plus y, this is equal to y. So we have fx is equal to y, then we can write for every y in codomain R, there exists x which is equal to 3 minus y by 4 in domain R such that fx is equal to y. Hence, f is onto. So whenever we have to show a given function onto, firstly we check fx is equal to y, then we express x in terms of y, then we show fx, then we bring fx is equal to y, and we write for every y in codomain R there exists 3y minus 4, there exists x in domain R such that fx is equal to y, hence f is onto. Let us do another question for into. So the question is, check whether f from n to n given by fx is equal to 2x is into. So we have to take a counter example for this function onto. If we check one belonging to codomain n, then 2x is equal to 1, this implies that x is equal to 1 by 2, which does not belong to domain n. It means that 1 in the codomain has not its pre-image. This implies that f is into. Let us see a visual diagram to understand onto and into functions. So we can see f1 here, that the elements of codomain is the image of an element of domain, or we can say that here range is equal to codomain. So this is onto. Here we can see that 1 is not the image, or we can say that here range is the set 2 3 4, and codomain is the set 1 2 3 4. Here we see that the range is proper subset of codomain, hence it is into. Let us do and know bijective function. So bijective function, a function f from x to y is said to be bijective if it is both 1 1 and onto. Let us know an example. So question number 5, let a and b be sets so that f from a cross b to b cross a such that f ab is equal to ba is bijective. For showing f bijective, we have to show it as 1 1, then as 1 2. So firstly we show it as 1 1. To show f is 1 1. To show f is 1 1. We know that for this we have to show fx1 is equal to fx2 implies that x1 is equal to x2. So let us assume a1 a2 in set A and b1 b2 in set B. Now if a1 b1 is equal to f a2 b2 implies that a1 here if ab is equal to ba, so it will be if a1 b1 will be b1 a1 is equal to b2 a2, right? Here we have to show that this implies that a1 is equal a1 b1 is equal to a2 b2. This implies that b1 is equal to b2 a1 is equal to a2, because we know that two ordered pairs are equal if and only if their corresponding elements are equal. This implies that a1 b1 is equal to a2 b2. This can be written as a1 is here, so a1 is equal to a2, that is here, b1 is equal to b2, that is here. So f is 1 1. Now to show f is on 2, we know that for showing f is on 2 we have to show there exists for every element y in the codomain there exists x in a domain such that fx is equal to y. So let us assume what is the way to show on 2. The way is we assume fx is equal to y, then we express x in terms of y, then we write for every element y in the codomain there exists an x in the domain such that fx is equal to y. So here let us assume f ab is equal to a3 b3. F ab is equal to here f ab is equal to ba. We can take f is equal to b3 a3 in codomain in b cross a, that is codomain. Be arbitrary, this is any element, this is any element of b cross a. Now we know that if ab is equal to, according to the definition, if ab is equal to ba, so we can write it as ba is equal to b3 a3. This implies b is equal to b3, a is equal to a3, because we know that two ordered pairs are equal if and only if their corresponding elements are equal. Now we have to show x in terms of y. So we can write AB as A3 B3. Now we take FAB. FAB is equal to F A3 B3, because we have obtained AB as A3 B3. This can be written as B3 A3 by the definition of F. So for every B3 A3 belonging to B cross A, there exists A B belonging to A cross B such that if AB is equal to B3 A3, so F is onto. Hence F is bijective. So for showing F onto, we have to assume Fx is equal to y. Then we express x in terms of y. The second step is we obtained Fx is equal to y. We have to show it. Then we write this line. Let us see its visual diagram. Here, no two distinct elements of domain have same image in codomain. Also, every element of codomain is the image. So, this will be bijective function. That's all in types of functions. You may do exercise 1.2, and if there is problem you can write in the comment.